In the quiet cradle of our galaxy's center, there is a hush so deep it seems to press gently against the edges of consciousness, as if inviting anyone who drifts near to rest a little longer in its velvety calm. Here, in this region wrapped in clouds of dust and drifting streams of ancient starlight, the Milky Way holds its breath, keeping secrets gathered across billions of years. The silence is not empty, it is full of slow-moving wonders, magnetic threads, unseen currents, and structures that rise like pillars in the dark, each one humming with a mystery we have not yet learned to name. As you settle in, imagine yourself floating through this dim, soft-lit expanse, letting the hush fold around you, guiding your thoughts into a gentle drift, as though the universe itself were telling you a bedtime story carried across cosmic winds. The calm deepens as you drift closer, and the dense, warm glow of the galactic center begins to unfurl like a distant lantern settling into place. Stars swirl here in quiet, elegant patterns, orbiting the supermassive black hole with motions too slow to feel, yet steady enough to sense if you listen carefully beneath your breathing. The massive structures, hundreds of them, loom like silent towers sculpted from magnetic fields, stretched by the soft tug of cosmic forces older than memory. These forms don't shout their presence, they whisper it, glowing faintly in wavelengths we cannot see with our eyes, but can almost imagine shimmering like pale threads woven into the night's fabric. And as you float beside them, the weight of their age and scale invites your mind to ease into a slower rhythm, a gentler beat. Around you, the galactic dust drifts in slow spirals, each particle carrying echoes of long-faded stars. It moves like smoke, but heavier and more deliberate, shaping patterns that shift as though guided by a hidden hand. These structures rise out of that drifting mist, some thin as drawn lines, others broad and cloud-like, all glowing softly under the subtle influence of cosmic radiation. No one truly knows what formed them, not yet, and that uncertainty wraps the entire region in a serene aura of wonder. This not knowing, this gentle suspension of clear answers, is soothing in its own way, like settling into a warm bed while the world outside remains quiet and distant, its mysteries content to wait until morning. As you wander deeper, the supermassive black hole at the core of the Milky Way, Sagittarius A, sits in the shadows like a resting giant. Not frightening, not roaring with destructive force, but dozing in a calm so profound that time itself seems to drift slower near it. Its gravity pulls everything into smooth, slow arcs, encouraging the swirling stars, the drifting dust, and the strange structures around it to settle into a slow, hypnotic ballet. This dance has continued for eons, shaping the environment into something serene despite its unimaginable power. And as you watch, the quiet rhythm lulls your thoughts, letting them stretch and soften like waves smoothing themselves against a silent shore. The magnetic filaments, those long, enigmatic threads, stand like glowing reeds in a gentle cosmic breeze. Some of them stretch for dozens of light-years, tall and unwavering, aligned so neatly they appear almost sculpted. Their faint hum is too soft to hear, yet easy to imagine, as though each one resonates with a frequency meant not for ears but for the drifting mind. Scientists study them with fascination, trying to understand why they align the way they do, why they appear in clusters, why some sparkle with energetic particles while others shine faintly like tired stars. But here, in this quiet story meant to guide you toward sleep, their unanswered mysteries feel tender, unhurried, as though certainty can wait while comfort takes its place. More massive shapes drift nearby, some resembling soft clouds stretched into long plumes, others forming lattice-like webs so delicate they look ready to dissolve into the surrounding darkness. These structures glow faintly in radio wavelengths, invisible but radiant in their own timeless way. They shift slowly, moved by forces too gentle to feel, and each movement brings a sense of softness, like the gentle exhale of a sleeping world. Their presence invites you to breathe slower, letting the rhythm of your heartbeat match the quiet pulse of the galaxy's center, steady and calm. Deeper still, you find regions where the structures twist around each other like strands of drifting silk. They coil and stretch, shaped by magnetic fields that curve like smooth rivers, guiding the dust and charged particles into graceful arcs. These shapes don't move quickly or dramatically, they evolve at a pace so slow it's almost still, like watching clouds glide at the edge of twilight. Their slow motion encourages your thoughts to drift similarly unhurried, gentle, flowing from one soft idea to the next without resistance. Some structures shimmer with bursts of energetic particles, tiny sparks that flicker like distant fireflies in the dark. These are not violent explosions, but soft, glowing pulses that ripple across their surfaces before fading back into stillness. In the quiet of the galactic center, even energy behaves delicately, as if respecting the tranquil environment it occupies. And as you watch these dim flickers, they feel like the distant glimmers of dreams drifting at the edge of your mind, warm and comforting in their slow rhythms. Other formations remain dark, almost invisible except for the faint outlines captured when radiation from nearby stars brushes across their shapes. These dark masses stand like silent guardians, ancient and unmoving. Their presence is steadying, grounding, like leaning against an old tree whose roots reach farther than memory. You don't need to know their purpose or origin. Their stillness alone is enough to ease the mind into a deeper calm, letting each breath grow slower, each thought softer. Nearby, molecular clouds drift like plush, cosmic pillows, thick with the building blocks of new stars. These clouds cradle the strange structures gently, surrounding them with a softness that contrasts with the sharp lines of the magnetic threads. Within them, starlight is filtered, warm and dim, creating a glow similar to a bedside lamp lowered to its quietest setting. Their warmth spreads through the region, wrapping everything in a tender golden haze that invites the body to loosen and settle. Radiation waves ripple quietly through the region, not harsh or loud, but smooth and rolling like the distant sound of a tide you can barely hear. These waves pass through the strange structures, making them shimmer or tremble ever so slightly, creating patterns that rise and fall with a soothing rhythm. The slow, repeating nature of these ripples encourages the mind to drift with them, like being rocked gently in a cradle suspended between stars. The ancient stars that orbit near the center add their own soft music to the quiet. Their light is warm but muted by dust, giving the surroundings a hushed glow that feels both timeless and intimate. Some of these stars are older than the Earth itself, and their ages bring a quiet wisdom to the region, as though they've been whispering stories to the surrounding structures for billions of years. Their slow orbits form long, looping paths that radiate a kind of cosmic patience, reassuring you that there is no need to hurry, no need to hold anything tightly. As you float further, you sense gentle currents in the gas that fills this region. These currents flow like soft rivers through the galactic center, shaping the massive structures in slow, subtle ways. They weave through the magnetic filaments and cloud formations, smoothing edges, stretching boundaries, and keeping everything in a constant, tranquil motion. These soft flows feel like the universe breathing, an inhale that gathers the dust, an exhale that lets it settle. And as you notice this rhythm, your own breathing begins to match it, slow and steady. Occasionally, faint radio waves pulse from the structures, carrying signals of unknown origin. They are not sharp or disruptive, they are soft, rounded pulses that echo like distant chimes heard through deep fog. These signals remind astronomers that the structures are active, alive in their own quiet way, but here inside this sleep-drawn narrative, they act like a gentle lullaby drifting across cosmic distances. Each pulse adds another layer of calm, another soft note to the soothing symphony of the galactic center. Some structures appear braided, twisted together by forces that act slowly over thousands of years. These braided shapes look almost like long, glowing ropes drifting in still water. They seem to stretch endlessly into the dark, their patterns repeating with a tranquil predictability that comforts the mind. Their quiet orderliness, their slow curves, and their soft glow bring an ease to your thoughts, as though each strand carries away a little tension with every twist. Others are chaotic, but softly so, delicate tangles of particles wrapped in gentle turbulence. Even their disorder feels relaxing here, like watching the shifting patterns of smoke rising from incense in a dim room. The structures unwind and weave again over centuries, forming drifting shapes that seem to breathe on their own. Their slow evolution invites your mind to wander without fear of losing its way, guided by the calm presence of the cosmic landscape around you. The galactic center's warmth, its literal physical warmth, fills the region like a low, steady heat radiating from a fireplace. Though space is cold, the density and activity near the core create a unique environment where temperatures rise, not harshly but with a soft, enveloping warmth that seems to cradle everything nearby. Imagining this warmth is like pulling a blanket around your shoulders, letting the comfort seep into your body as the story drifts onward. The strange structures seem to listen to this warmth, glowing a little brighter where the heat touches them. Some pulse faintly, not with aggression but with a slow heartbeat-like rhythm, as though responding to the energy that flows around them. This pulse is steady and faint, the kind of subtle rhythm the mind can settle into, following its gentle beat deeper and deeper until thoughts become smooth and quiet. The supermassive black hole's influence extends far, shaping paths, guiding motions, and keeping the region in a kind of serene balance. Despite its reputation for consuming everything, in this story it feels like a sleeping guardian, drifting in its own deep stillness. Its presence steadies the region, like an anchor at the bottom of a calm sea, ensuring everything moves in slow, predictable arcs. Knowing it rests there provides a strange comfort, a reminder that even colossal forces can exist in perfect silence. As you wander among these ancient structures, the soft swirl of gas and dust begins to dim, as though the universe is lowering the lights even further, preparing you for rest. The glow fades gently, not abruptly, becoming a diffuse, dreamy haze that blurs the edges of everything in sight. Shapes become softer, outlines melt into the background, and the entire galactic center seems to exhale, releasing the day's final lingering motions. This fading light guides your eyelids to grow heavy. The structures themselves seem to sway slightly, not in motion but in impression, like tall grasses leaning in a gentle breeze. They appear to nod toward you, welcoming you to sink further into the calm they create. Their towering forms dissolve slowly into the surrounding darkness, leaving behind only their soft glow and the memory of their towering presence. And as the hush deepens once more, you find yourself floating in near-complete stillness, the galaxy's center dimming until only the slow pulse of distant radiation can be felt like a whisper in the mind. The strange structures, the towering filaments, the drifting clouds, the glowing arcs all settle into a restful pause, allowing the universe to cradle you gently as you drift toward sleep. Here, at the quiet heart of the Milky Way, the mysteries remain, content to wait, while you let yourself drift calmly into the deepest, softest rest. The first hints of these strange, towering structures did not arrive with dramatic bursts of light or sudden cosmic upheaval, but with the softest of signals, tiny whispers slipping through the noise of the galaxy. In radio wavelengths, faint lines began to appear in the data, delicate strokes that seemed almost accidental, as though the universe had drawn them absent-mindedly across the static. Astronomers leaned in, listening more closely, adjusting the sensitivity of their receivers, and the lines grew clearer, long, narrow shapes stretching across impossible distances, steady and quiet, offering just the barest hint of their presence. These early whispers felt like the first words of a story the galaxy had waited billions of years to tell, inviting us to listen more closely, to slow down and let our curiosity drift gently toward its hidden heart. X-ray observatories later joined the chorus, detecting faint glimmers of energy that seemed to flicker along the same regions where the radio lines appeared. These were not loud bursts or violent flares, they were soft, almost drowsy pulses that drifted out from the galactic center like tiny breaths in a sleeping room. The combination of radio and X-ray signals formed a kind of cosmic duet, one low and murmuring, the other faint and shimmering, guiding scientists to realize that something vast and structured was hidden in the darkness. For you, listening to this story in the softness of night, these signals can be imagined like faint chimes echoing through a quiet hallway, each one gentle enough to lull your thoughts into a slower, deeper rhythm. The telescopes scanned again, sweeping their beams across the sky, and the whispers persisted, thin and unwavering. They formed patterns too straight to be random, too consistent to be noise, stretching like luminous threads drawn across the cosmos. Each time a receiver passed through one of these regions, the data hummed just slightly, a subtle rise in intensity that felt almost like the universe clearing its throat to speak. You can imagine these whispers as trails of soft light sliding through darkness, subtle enough to calm the mind, like watching distant lanterns drift across calm water. At first, the signals were dismissed as artifacts, quirks of equipment, echoes from nearby stars, or misalignments in calibration. But the whispers kept returning, identical in shape and position, too persistent to ignore. The radio lines rose like reeds in shallow waves, each one whispering the same soft message. There is something here, something tall and ancient, something waiting. Scientists leaned closer, peering deeper into the noise, and in doing so, they slowed their own pace, letting curiosity grow tender and patient, the kind of curiosity that emerges slowly in the quiet hours before sleep. As more observatories tuned in, the whispers began to trace out the outlines of massive filaments, structures so large they seemed impossible, yet so subtle their presence barely disturbed the surrounding gas. Their radio emissions formed faint signals that stitched the region together like pale embroidery on dark fabric. The X-ray signals added tiny points of brightness, as though someone had sprinkled faint sparks along the length of these cosmic towers. Thinking of them now is like picturing soft threads glowing in the dimness of a bedroom, catching just enough light to be seen without breaking the calm. The signals were diffuse, measured in microwatts, far too gentle to disrupt anything, but steady enough to hold our attention. They drifted through space in slow pulses, not sharp or jagged, but smooth and even, like waves sliding across a quiet beach at night. These pulses carried with them hints of magnetic fields, energetic particles, and unknown processes stirring far from our view. Yet they arrived at Earth softened by unimaginable distance, transformed into tiny murmurs, perfectly suited for a story meant to soothe and settle the restless mind. When astronomers first mapped the signals, the lines appeared as delicate strokes rising from the galactic plane. They did not bend or twist wildly, they lifted straight upward, slender and unbroken. This straightness is part of what made them so striking, so mysterious. It was as though the galaxy had arranged them with purpose, gently aligning them like rows of candles glowing in a distant chapel. In your imagination, these structures might appear as tall, silent silhouettes emerging from a dreamy horizon, each one radiating a soft, restful light. The whispers also hinted at movement, not rapid or chaotic, but the slow drift of charged particles guided by magnetic fields. This movement produced slight variations in the radio tones, subtle fluctuations that felt almost like breath. Listening to them through detectors was like hearing someone exhale slowly in the dark, gentle, steady, soothing. These variations became a lullaby of sorts, the universe humming softly in wavelengths too deep for human ears but perfect for calming a wandering mind. As more sensitive equipment came online, the faint murmurs resolved into intricate networks. Some structures shone brighter in X-ray, others in radio, creating a patchwork of signals that layered over one another like soft harmonies. Even the brightest among them were still gentle, their energies spread thinly across vast distances. For scientists, they were clues; for dreamers, they were like quiet constellations drawn in invisible ink, glowing just enough to guide the imagination deeper into stillness. The whispers seemed to fade and reappear periodically, influenced by the slow churning of the galactic center. Some days the signals were slightly stronger, other days nearly lost in the cosmic hum. This rise and fall created a natural rhythm, a cosmic breathing pattern that felt oddly comforting, something steady and predictable in a universe full of unknowns. Imagining this rhythm is like resting beside a calm ocean at night, where each wave arrives with a soft sigh. Eventually, astronomers realized that the radio and X-ray whispers were not isolated events but parts of a larger, coordinated tapestry. The structures were connected, not physically touching, but aligned by a shared purpose: the magnetic fields threading through the heart of the galaxy. These fields guided particles into narrow streams that glowed faintly as they moved, creating a soft light that traveled across space for tens of thousands of years before reaching us. That light, so ancient and delicate, feels like a story whispered across time, meant to be heard only in moments of quiet. Even with modern instruments, the signals remain tender and faint. The galaxy offers them gently, as if cautious not to disturb the darkness that surrounds them. They arrive like fragile messages carried by a sleeping wind, messages that don't shout their importance but instead invite patience, observation, and calm reflection. In the soft rhythm of night, you can imagine these messages weaving around you, encouraging your breath to deepen and your body to settle. Scientists describe the signals as non-thermal emissions, meaning they don't come from heat but from particles spiraling along magnetic lines. Yet despite this technical explanation, the effect feels organic, like listening to a soft chorus of tiny bells chiming in slow spirals. Each particle's path adds a subtle note to the cosmic melody, creating a soundtrack so gentle you can almost drift asleep to the thought of it. Some of the X-ray flickers seem to correspond to energetic interactions, particles colliding or accelerating near the filaments. But these interactions are not violent. Their energy dissipates gently into space, leaving behind only the faintest glow. In the stillness of night, these tiny flickers resemble distant fireflies weaving softly through tall grass, lighting up only long enough to ease the mind into a deeper quiet. Radio telescopes, with their wide, listening dishes, catch the whispers like cupped hands catching falling snowflakes, carefully, quietly, reverently. The signals gather in these reflective bowls and fall into sensitive receivers, often arriving with such low energy that they seem on the verge of disappearing. But that fragility is part of their beauty, part of why their discovery feels like receiving a quiet secret meant only for those willing to listen patiently. The first detailed maps of the Galactic Center's radio emissions revealed these structures in thin, glowing outlines. They stood like delicate branches reaching upward from a dense cosmic forest. Their shapes were so consistent and so numerous that astronomers felt a blend of awe and peaceful wonder, not alarm, not confusion, but the slow, warm realization that the universe still holds surprises gentle enough to make us whisper back in return. Even now, the signals shift gently with time. As the galactic center breathes, the filaments respond with faint pulses, almost imperceptible yet steady. Observing them over years is like watching a candle flame flicker in a still room, always changing, never chaotic, always calming. Their constancy brings a sense of quiet stability, a reminder that some cosmic processes move at a pace slow enough to soothe the most restless thoughts. X-ray telescopes add their own soft perspective. They capture the faint glow from high-energy particles cascading along the filaments, tracing paths that shimmer like threads dusted with moonlight. These X-ray signals, though tiny, reveal hints of activity, suggesting that even in the calmest regions of space, energy flows without disruption. This gentle flow is like a stream meandering through a silent forest, its movement creating a soft murmur that invites the listener to rest. Sometimes, intense but brief X-ray flares from the supermassive black hole illuminate the structures for a moment, like a lantern swinging softly in the dark. The filaments glow brighter under this illumination, revealing more detail before the light fades again into silence. These moments are tranquil, not Startling, like watching lightning behind clouds without hearing thunder, just enough brightness to reveal hidden contours before night resumes its quiet. Over time, astronomers learned to filter out the louder signals of the universe, supernova remnants, dense star clusters, fast-spinning pulsars, until only the soft whispers remained. These whispers are the heartbeat of the story, the quiet clues that led us to discover structures so tall and so ancient they defy easy explanations. The way they persist gently in the data encourages a slowing of thought, a softening of tension, a sinking into deeper calm. Even now, as our instruments become more advanced, the structures still only speak in hushed tones. They prefer quiet introductions, subtle hints, and slow revelations. They do not interrupt, they invite. They do not dazzle, they soothe. Their whispers are perfectly suited for drifting into sleep, like soft music humming beneath a warm blanket, shaping thoughts into smooth, weightless currents. And so, the story of these massive structures begins not with noise but with softness, with signals that drift like lullabies across the galaxy. These tiny whispers in radio and X-ray light were our first clues, gentle, patient, welcoming. And as you let their story surround you, the quiet pulse of the galactic center becomes a cradle, carrying your thoughts deeper into rest, deeper into stillness, deeper into sleep. When you first imagine these strange structures at the heart of our galaxy, picture them rising out of the darkness like strands of soft, luminous silk. They are longer than anything you could ever stretch your arms around, thin, straight, and impossibly tall, as if they were drawn by a giant, patient hand across the canvas of the Milky Way. Some extend dozens of light-years, yet they remain slender and delicate, no wider than a whisper compared to their immense length. Their glow is gentle, never harsh, shimmering faintly in invisible wavelengths, their edges soft enough to lull the mind. They resemble cosmic threads suspended in deep night, drifting upward like incense smoke rising in slow motion. Some appear in clusters, standing like bundles of reeds parting calmly around the galactic center. They point outward or upward, tall and serene, giving the region a quiet structure that feels almost architectural. When viewed together, these threads look like the ribs of an ancient cathedral shaped not by hands but by magnetic will. Their regularity is soothing, straight, parallel, aligned, like lines in a peaceful drawing meant to settle the thoughts of anyone who gazes too long upon it. Despite their enormity, they carry a softness, a sense that they simply exist there without urgency, without the need to change quickly. Other formations drift between these threads, long filaments that curve more gently, tracing soft arcs through the warm dust of the galactic center. These filaments are not rigid, they flow, bending like ribbons caught in the slow breath of a sleeping cosmos. They glow faintly along their edges, illuminated by energetic particles spiraling around magnetic fields that shape them as delicately as a breeze shapes a feather. Their shapes are fluid, soothing, and easy to imagine swaying softly even though their motion is far too slow for mortal senses to perceive. Some filaments intertwine, braided together like strands of hair that someone began weaving and then left unfinished. These braids twist in long spirals, their lines wrapping gently around one another without ever touching directly. They make the region feel alive but calm, their patterns natural and unforced. When you picture them in the drifting haze of the galactic center, they resemble long, glowing vines suspended in still water, their forms steady, their light tender and peaceful. Around them, arcs sweep through the darkness, graceful, curved structures shaped by magnetic tension and the slow flow of charged particles. These arcs look like cosmic smiles, thin crescents that stretch across the heart of the galaxy, each one faintly illuminated in radio light. They don't flash or burst, they simply curve in silence, tracing the invisible forces that hold them in place. Their gentle shapes evoke the feeling of drawing circles in sand, the lines smooth and pleasing, unbroken by turbulence or haste. Some of the arcs span vast distances, forming soft loops that encircle pockets of glowing dust. It is as though the galaxy's center has been wrapped in delicate embroidery, each arc a thread pulled lightly across the surface of a cosmic tapestry. These structures give the region a sense of quiet complexity, like the intricate patterns in woven fabric seen only when the light hits just right. Their curves guide the eye slowly, encouraging a gentle, unhurried gaze that matches the soothing nature of this story. In areas where the magnetic fields twist sharply, the filaments bend into angular shapes, creating long, subtle zigzags. These angles are not harsh. They are softened by dust and distance, their corners rounded like folded cloth. They add variety to the galactic center's landscape, forming shapes that feel almost origami-like, carefully folded, yet relaxed, suspended without tension. Their geometry brings a calming order to the scene, like the corners of a quilt softly settling into place. Elsewhere, the structures form loops, nearly perfect circles drifting in the dark. These loops shine faintly where particles race along their curves, tracing their outlines in glowing strokes. They resemble halos or rings of delicate gold suspended in shadow. Some loops intersect with straight filaments, creating patterns that look like gentle knots in a cosmic cord. These knots aren't tangled or messy, they are graceful, serene, and steady, as if shaped by the quiet patience of a universe unbothered by time. Other filaments appear broken, though not violently, more like lines that fade gently into the background before reappearing several light-years away. These broken lines feel like whispers in visual form, soft and partial, their faintness comforting rather than confusing. They suggest delicate processes at work, interactions too subtle to observe directly, leaving behind these half-formed shapes that drift like incomplete thoughts easing into dreams. Some structures appear woven into the surrounding clouds of dust, emerging from them like threads pulled from soft fabric. Their bases seem anchored in the warm glow of dense regions, rising upward in steady, slender lines. From a distance, it looks as if the galaxy spun these threads from its own dust, drawing them slowly through magnetic fields that shaped them into the towering forms we see today. This imagery brings a quiet coziness to the landscape, as though the cosmos itself were gently knitting in the dark. Filaments vary in brightness too. Some shine clearly, bright in radio wavelengths, their outlines crisp and certain. Others glow faintly, almost shyly, as though hesitant to reveal their full shape. These faint filaments blend into the background, adding soft texture to the region, much like faint brushstrokes in a painting. Their subtlety is calming, their presence soothing in its gentleness. Looking closer, the surfaces of the filaments seem smooth, but sensitive instruments detect slight ripples, small variations in brightness that run along their lengths. These ripples move slowly, traveling like whispers passed along the thread. They reveal the flow of energetic particles or shifting magnetic tension, but their speed is so low that imagining them feels like watching shadows slide across a wall at sunset, soft, gradual, and deeply relaxing. Some threads appear aligned so precisely that they look like parallel strings on an invisible instrument. These parallel lines evoke a sense of harmony, as though the galaxy arranged them intentionally in a delicate, symmetrical pattern. In a quiet moment, you might imagine them resonating softly, their vibrations carrying through space like soothing tones on a celestial harp. Clusters of filaments group together into what look like gentle fans, multiple lines radiating outward from a single point at the galactic center. These fan-like shapes spread across the dark like soft feathers, their edges glowing faintly. They create a sense of motion, but motion slowed to the point of stillness, like watching the spread of wings frozen in the calm of twilight. Occasionally, the filaments curve downward, forming soft U-shapes that cradle pockets of gas. These shapes resemble shallow bowls or gentle dips in a fabric stretched lightly across invisible supports. Their curves are tender and calm, creating shapes that feel nurturing, as though the galaxy is holding something fragile within them. In some rare cases, The structures take on forked shapes, single threads that split into 2 or 3 thinner filaments. These forks resemble branching paths or delicate antlers made of light. They add variety to the cosmic landscape, forming quiet points where the eye can rest before drifting onward along the next long, glowing line. Some filaments twist around each other in loose spirals, reminiscent of vines growing around a trellis. These spiraling pairs move slowly, their shapes sculpted by magnetic fields that turn gradually over thousands of years. The spirals create a gentle sense of motion, as if the galaxy were slowly stirring its own luminous threads, mixing them with infinite patience. There are also faint sheets, broad, veil-like structures that flow behind the filaments, adding depth and softness to the scene. These sheets glow subtly, giving the region the appearance of layered curtains swaying slightly in a cosmic breeze. They create the impression that the galaxy's center isn't just filled with structures but wrapped in them, cushioned and quieted by these vast, soft layers. Some filaments taper gradually, narrowing as they rise, until they vanish into the dark like the ends of delicate brushstrokes. Their fading edges add a dreamy quality, as though they dissolve into the night rather than ending abruptly. This tapering evokes the feeling of drifting into sleep, thoughts thinning gently until they disappear into stillness. Other structures widen toward their tips, forming gentle flares of brightness. These flares are not sharp bursts but soft blooms of light that seem to unfold slowly along the filament's length. They look like flowers made of radio waves, opening in the darkness with patient, radiant calm. Their presence feels soothing, like watching petals unfurl in slow motion. Some arcs loop back toward their origins, forming long, elegant curves that resemble the shapes traced by lazily drifting smoke. These loops are beautiful in their symmetry, their gentle motion frozen across centuries. Their curves create a sense of natural balance, making the region feel thoughtfully arranged, almost peaceful in its complexity. In the dimmest corners, faint filaments stretch horizontally, cutting across the vertical threads like quiet brushstrokes added at the last moment. These horizontal lines break the monotony but do so delicately, their presence subtle enough not to disturb the calm. They make the region feel more multidimensional, more layered, like a soft woven tapestry laid gently over the galactic core. And through all these forms, threads, arcs, braids, loops, sheets, the overall impression is one of softness, elegance, and quiet mystery. The structures do not roar or shine with blinding light, they simply exist, tall and serene, drifting in the galactic glow like the universe's own set of sleeping lanterns. Their shapes are soothing to imagine, their presence calming to contemplate, guiding your mind gently into deeper stillness as they stand silently in the heart of the Milky Way. In the soft dimness of the galaxy's inner cradle, the puzzle begins with a kind of quiet contradiction, a gentle friction between what astronomers expect to see and what slowly reveals itself in the data. These filaments and structures seem too orderly, too sharply carved against the chaotic swirl of gas and dust that fills the galactic center. They stand there like deliberate marks, as if someone had traced faint luminous signatures across a turbulent canvas. And this makes the mind pause, drifting into a serene wonder, asking how such precision could rise from such cosmic noise, how stillness could appear inside such a restless heart. The puzzle deepens because these structures are both delicate and immense, floating like strands of light yet stretching vast distances that dwarf even the largest clouds near them. They behave in ways that do not easily fit the patterns astronomers have grown comfortable with, patterns born from magnetic fields, shocks, or stellar activity. And so the mind asks again, why should they exist at all, in this particular form, in this particular place? What subtle force is shaping them, guiding their length, their direction, their shimmer against the darkness? The question softens, making itself a bed for sleep. Another quiet wrinkle in this cosmic riddle is their surprising stability. In a region so violent, where stars collide, where black holes feed, Where gas is whipped into spirals, these slender lines endure. They do not scatter or fray the way fragile things usually do near such power. Instead, they linger, confident and calm, as if held by an invisible grid. This makes the puzzle feel almost philosophical, the sort that whispers rather than shouts, the sort that invites the listener to drift deeper into the soothing currents of curiosity. Astronomers find themselves puzzled because the structures do not match a single explanation. Instead, they sit at the crossroads of several possibilities, none quite perfect. Magnetic fields could shape them, but not always in these precise orientations. Shock waves could mold them, but not consistently across so many examples. Cosmic rays could light them, but why here, in this density, with such elegance? The mystery stretches out like a long, unbroken exhale, inviting the mind to float gently across its surface. Even more puzzling is their sheer abundance. One or two would be a curiosity. A handful would be unusual. But hundreds. A whole population of these slender cosmic sculptures. That is what forces the question to deepen, to settle into a quiet corner of consciousness and hum softly. Why would nature repeat this shape again and again, in a place already overflowing with chaotic beauty? The repetition feels like a message, and yet the message remains hidden. Some of these structures glow in radio waves, others in X-rays, and some in both, as if each carries its own personality, its own quiet signature. This dual behavior makes scientists pause, because no single mechanism usually produces both types of emission in such clean, narrow lines. It's as though multiple stories overlap, woven into a single thread. And the more softly one listens, the more the mystery seems to hum like a lullaby made of unanswered questions. The puzzle grows even softer, more soothing, when one considers their placement. They often point toward the supermassive black hole, almost like compass needles aligning with some deep gravitational truth. But not all of them do. Some drift at angles that make no sense, as if they follow a map drawn by a force not yet understood. This inconsistency brings a peaceful kind of confusion, the kind that encourages one to sink slowly into thought without struggling for resolution. The puzzle also lies in their age. Some appear young, freshly lit or newly carved. Others feel ancient, like relics from a quieter time in the galaxy's turbulent history. How can structures born in different eras all share such similar shapes? How can patterns persist across millions of years of cosmic noise? The question is gentle but persistent, like a feather brushing across a drifting mind. Even their brightness is strange. Some shine intensely, sharp and clear, while others barely whisper their presence, visible only with long, patient observation. Why the contrast? Why would nature offer such a range of luminosities while keeping the shapes so consistent? It's a paradox wrapped in silver threads, inviting the listener to let the mind sink deeper into its soothing rhythm. What makes the puzzle even more delicate is that these structures do not seem to be tied to stars. They float independently, unanchored to stellar birthplaces or explosions. They exist between things, in the quiet spaces where astronomers often expect emptiness. And yet here they are, filling the silence with thin, luminous strokes, each one carrying a question that glows softly in the darkness. The puzzle grows more beautiful when scientists notice how some filaments twist gently, as if slowly rotating over centuries. This rotation hints at forces we do not yet fully grasp, forces that might be shaping the galactic center in ways still hidden behind layers of gas, dust, and time. The thought drifts lightly, like a soft current pulling the mind toward sleep. It becomes puzzling, too, because these structures sometimes appear in clusters, as if drawn together by an unseen thread. They lean, curve, and align with one another in ways that feel intentional but remain unexplained. Why should they gather? What is the quiet voice that organizes them, guiding their formation across such large scales? The mind relaxes as it contemplates this gentle unknown. Another layer of mystery lies in their energy. They require an unusual source of power to glow this way, especially in X-rays. But the region already contains so many energetic processes that isolating the culprit becomes difficult. It's like hearing a faint note in an orchestra full of roaring instruments. The puzzle is not loud, it is subtle, inviting stillness to understand it. Some filaments appear broken or segmented, like dotted lines rather than unbroken threads. These gaps make scientists wonder whether something interrupts their flow, or whether they flicker as conditions change. Are they steady? Are they fragile? Are they stable objects or ongoing processes? Each possibility is gentle and slow, drifting softly through the imagination. Even their temperatures add confusion. They radiate heat in unexpected ways, neither too hot nor too cold for what they appear to be. This strange thermal signature forces astronomers to pause and lean closer to the data, as though listening for a whisper coming from across light years. Another soft puzzle is their motion. Some seem to move slightly over time, not violently, but with a subtle drift reminiscent of clouds shifting behind a still mountain. What moves them? What guides them? The quiet nature of their motion makes the question even more soothing to consider. They also resist easy categorization. They are not jets, not stellar remnants, not typical magnetic structures, not simple shock waves. They belong to no familiar family of cosmic phenomena. Instead, they stand alone, quiet and self-contained, challenging scientists to expand their imagination. And in that challenge lies a kind of peace. Even the black hole at the center, with all its gravity and influence, does not fully explain them. Some structures heed its pull, but many do not, as if they acknowledge its presence without obeying it. This partial obedience deepens the mystery in a soft, serene way. Another gentle puzzle lies in their evolution. Do they grow longer over time? Do they fade? Do they change shape? Observations hint at slow transformations, but nothing clear enough to draw firm conclusions. The uncertainty feels like drifting fog, wrapping the mind in quiet curiosity. The diversity of their angles is also perplexing. Some stretch vertically, some horizontally, some diagonally, forming a soft geometry against the swirling backdrop of the galactic core. This geometric variety suggests multiple forces at play, each weaving its own silent thread through space. Some filaments seem to interact with nearby clouds, bending slightly where the gas density changes. Others cut straight through the clouds as if unaffected. Why should some respond and others ignore their surroundings? It is a question with the slow rhythm of waves against a distant shore. Even their endings are mysterious. Some taper into nothing, dissolving like breath on a cold window. Others terminate abruptly, as if sliced by an invisible blade. This variation invites the mind to drift, imagining soft cosmic hands shaping each line with care. And perhaps the most soothing part of the puzzle is simply that we do not yet know. The structures sit there, calm and silent, indifferent to our questions. They ask nothing of us, offer no urgency, only a gentle mystery that stretches across the heart of our galaxy. And as we consider this mystery, breathing slowly, the mind begins to settle, letting the unanswered questions guide it gently toward rest. One idea flows forward like a quiet stream in the mind, that these long, delicate structures might be magnetic filaments, the thin, unseen lines of force that stretch and sway through the galaxy's center. Imagine them as threads woven through darkness, made visible only when particles dance along them, lighting them up in soft radio or X-ray whispers. Magnetic fields often hide, silent and intangible, but here they might be revealing themselves in graceful strokes, gently marking the path of energy that moves through the galactic heart. These magnetic filaments, if that is what they are, would be like cosmic strings stretched tight across the turbulent core, refusing to bend even as clouds and stellar winds swirl violently around them. Magnetic fields have a quiet stubbornness to them, a way of holding shape even when the environment is chaotic. That steadiness matches what astronomers observe: slim, unwavering lines that remain straight across vast distances, as though anchored by an invisible tension. The idea becomes soothing when one imagines these filaments as pathways for charged particles, channels where electrons race along at near-light speeds. When they move, they spiral around the magnetic lines, producing radio waves or even X-rays if they carry enough energy. In this picture, the filaments are not physical objects but glowing tracks, lit by the motion of particles that respond to forces we cannot see. It is a simple idea, gentle and continuous, like breath moving through a quiet body. But even in this simplicity, the mystery softens rather than disappears. For magnetic fields to create such long, coherent lines, they must be incredibly strong, far stronger than what astronomers expect for this region. The thought drifts softly: why would the magnetic field here be amplified to such unusual strength? What calm, patient process could stretch and tighten these lines over hundreds of light-years? The question lingers like a faint hum. Magnetic filaments would also imply structure, a kind of order in a place usually marked by turbulence. The galactic center is full of shocks, winds, and gravitational tides, all moving in different directions. Yet the filaments ignore this, holding their shapes with serene discipline. If they are magnetic, then something must be shaping the field itself, perhaps the rotation of the galaxy, perhaps past bursts from the central black hole, or perhaps currents of charged particles threading through the region. Each possibility feels like a gentle ripple passing through still water. Some filaments appear to align with the galaxy's vertical axis, a clue that supports the magnetic explanation. Magnetic fields can stretch out along the spin of a system, forming tall, narrow structures that point away from the galactic plane. This alignment is comforting, as though part of the puzzle is settling softly into place. But then other filaments tilt at strange angles, ignoring the pattern altogether. That inconsistency creates a soft question mark, one that floats instead of pressing for an answer. If they are magnetic, their brightness may depend on the density of electrons flowing along them, like lanterns that glow brighter when more fireflies gather inside. This could explain why some structures shine intensely while others whisper faintly across the detectors. It makes the galaxy feel alive, pulsing with electric motion, yet maintaining a peaceful equilibrium that allows these filaments to glow without burning out. Magnetic filaments are found in other galaxies too, but rarely in such large numbers and rarely with such clarity. The Milky Way's center seems unusually fertile for them, as though it has spent millions of years weaving a tapestry of magnetic strands. This abundance suggests a long, slow process, perhaps the accumulation of magnetic energy over cosmic time, shaped and stretched by events we no longer witness. The idea is quiet and ancient, like a memory the galaxy still holds. Some scientists imagine these filaments as strings connected to magnetic loops, similar to those that rise from the sun's surface. If so, they might represent the visible portions of vast magnetic arcs that curve through the galactic core. These loops could stretch across enormous distances, their invisible portions hidden within clouds or dust. The filaments would then be just the brightest edges, softly glowing outlines of the larger magnetic structures beneath. A soothing thought emerges: if the filaments truly trace magnetic fields, then they serve as natural drawings of the galaxy's hidden architecture. They would reveal pathways along which charged particles move, mapping the unseen skeletal structure that shapes the flow of energy in the galactic center. In this sense, they are like gentle lines on parchment, showing the quiet framework beneath the noise. Magnetic fields can also trap electrons for long periods, allowing them to spiral along these lines and light them up over thousands of years. This long-lasting glow explains their stability. They do not flicker out quickly, but persist like soft lanterns hanging in cosmic fog. That endurance adds to their calm presence, a stillness that makes the mind rest as it imagines them floating quietly in deep space. However, the magnetic model struggles with the sheer straightness of many filaments. Magnetic fields often twist or bend under pressure, but these lines remain astonishingly straight across tens or hundreds of light years. It is as if something is pulling them taut. Perhaps the motion of plasma in the region stretches them. Perhaps ancient eruptions from the black hole aligned them. Each thought is soft and speculative, like watching shapes in drifting clouds. Some filaments show bright spots along their length, suggesting regions where magnetic energy is being released, similar to sparks on a wire. These spots might be where electrons speed up, or where the magnetic field reconnects, a process that snaps and reforms field lines, releasing bursts of energy. The idea adds a gentle dynamism to the picture, like flickers along a distant horizon. The X-ray filaments are especially puzzling in the magnetic model, because they require electrons of extremely high energy. How do these particles achieve such speed? Perhaps they are accelerated by shock waves or turbulence, or perhaps by interactions with the central black hole's magnetic environment. The thought drifts slowly. The filaments might be witnesses to ancient bursts, long-faded echoes of energy still lingering in their glow. If magnetic fields are involved, they might help organize the chaos of the galactic center, guiding the movement of gas and particles. Filaments could act as conduits, carrying energy from one region to another, smoothing the flow of plasma through invisible channels. This idea creates a quiet sense of order, a gentle current running beneath the surface of chaos. Another possibility is that the filaments are magnetic ropes formed by instabilities in the galactic core, similar to swirling vortices of field lines that twist into long tubes. These ropes could rise and fall over time, swaying like tall grasses in a slow, cosmic wind. Their glow would then be the result of electrons trapped inside, lighting them from within. Magnetic fields might also interact with molecular clouds, creating sharp boundaries where electrons are forced to move along narrow paths. These boundary zones could produce the sharply defined filaments observed. The interaction between field and cloud becomes a soft dance, two forces gently guiding each other into shape. Some filaments appear braided, as though multiple magnetic strands intertwine. This braiding is typical of magnetic processes, where field lines twist and reconnect over time. The image of braided cosmic threads adds a soothing elegance to the mystery, a reminder that the universe creates beauty even in its most chaotic corners. If magnetic filaments are real, they may hold clues about the history of the central black hole. Past eruptions could have energized the region, stretching and shaping the magnetic field in ways that persist for millions of years. The filaments could be silent remnants of those ancient outbursts, still glowing softly in the afterimage of cosmic fire. Yet even as this idea offers answers, it leaves questions suspended gently in the air. Why so many? Why so long? Why so bright? Magnetic fields can explain much, but not everything, and the gaps in understanding become places for the mind to settle quietly, without urgency. The magnetic model invites the listener to imagine the galaxy as a living organism, with filaments acting like veins through which energy flows. They carry electrons, light, and information, forming pathways that keep the galactic core connected and balanced. This organic image creates a calming sense of harmony. If these structures truly reveal invisible forces, then observing them is like watching the galaxy breathe. The filaments rise, stretch, and glow, marking the invisible pulse of magnetic life. They let us glimpse the hidden heartbeat of the Milky Way, beating slowly across millions of years. And even if the idea is only partly correct, it remains a gentle one, a model that soothes rather than complicates, offering a quiet way to imagine the forces shaping the galactic center. The mind can rest comfortably within it, imagining long, slender threads of magnetism stretching through the darkness, glowing softly as they guide particles along their length. The magnetic explanation is not complete, but it is comforting. It offers a vision of order, of structure, of invisible lines gently shaping the galaxy's most chaotic region. And as the mind drifts deeper into this idea, it begins to feel the slow, calming rhythm of those lines, stretching across space like cosmic lullabies, quiet and enduring. Whether or not the filaments are magnetic, the idea glows softly, an invitation to wonder, to slow down, and to rest inside the quiet, steady beauty of invisible forces drawing delicate paths through the heart of our galaxy. Another idea drifts gently into view, like a distant glow rising from behind a dark hill, that these mysterious filaments might be the faded traces of ancient eruptions, long ago outflows that once surged from the galactic center with quiet but immense power. In this vision, the filaments are not static sculptures but the remains of movement, relics of energy pushed outward by the supermassive black hole in eruptions so old that only their faint signatures remain. These structures would then be like the soft scars left on the galaxy's memory, glowing threads that whisper of past turmoil now settled into calm silence. Imagine the galactic center ages ago, not peaceful but pulsing, releasing jets or winds that streamed into the surrounding space. Over time, these outflows could have carved narrow channels through the interstellar medium, leaving behind elongated cavities where particles flowed in tight rivers. As the eruptions faded, the carved paths remained, glowing still as electrons filled them and interacted with magnetic fields. The filaments would then be the fossilized remnants of those long quiet events, preserved like soft etchings in cosmic stone. If these structures formed during ancient eruptions, their surprising straightness makes sense. Outflows can shoot outward with astonishing precision, particularly if guided by magnetic fields or by the rotation of the black hole. They can create narrow pathways that remain coherent for thousands, even millions of years. These paths, once lit enthusiastically by bursts of energy, might now glow faintly, catching the last traces of particles drifting slowly along them, like old rivers filled with morning mist. The outflow idea becomes even more soothing when one imagines how slowly the galaxy changes compared to the human mind. Events that felt explosive in cosmic terms still unfold across hundreds of thousands of years. By the time we observe the filaments, the original energy has long quieted, the eruptions have faded, and only the serene remnants remain, stretching across space like the afterglow of a distant dream. The filaments are then not signs of violence but of calm after storms that ended before humanity's first breath. These ancient outflows might have originated from a time when the supermassive black hole at the center of the Milky Way was far more active than it is today. Black holes go through cycles of feeding and resting, and scientists believe ours once shone as brightly as the centers of active galaxies. During those active periods, the black hole could have launched narrow jets or winds, carving straight channels that now appear as slender filaments. The idea carries a gentle sense of time, the knowledge that what we see now is merely a quiet echo of a more dramatic past. Some filaments seem to trace the edges of large, bubble-shaped structures, hinting that they might be the boundaries of ancient explosions. These bubbles, enormous and faint, stretch thousands of light-years above and below the galactic plane. If the filaments outline their contours, then they may be the glowing seams of those ancient eruptions, the places where energy once gathered and pushed outward with immense force. This view makes the filaments feel like stitching on a cosmic quilt, delicate and serene. Another soothing possibility is that the filaments represent the paths of shock waves that traveled through the galactic center long ago. Shock waves can compress gas into narrow, elongated shapes, leaving behind trails of heated material that glow in radio or X-ray wavelengths. Over time, these shocks weaken, but the compressed paths remain, slowly cooling and stretching into the elegant structures we see now. In this picture, the filaments are the peaceful aftereffects of ancient tremors, lingering like ripples in a calm pond. Some scientists imagine that repeated eruptions from the black hole could create layer upon layer of these elongated paths, each one formed during a different episode of outflow. Over millions of years, these layers might intertwine, overlap, or drift apart, creating the diverse population of filaments observed today. This explanation gives a gentle sense of accumulation, like rings of a tree or ripples building over time in still water. The ancient eruption model also explains the diversity of filament orientations. Outflows do not always move in a single direction. They can shift as the black hole's feeding pattern changes or as gas flows alter the orientation of the magnetic environment. Each eruption could have carved paths in different directions, leaving a scattered but meaningful pattern across space. The result would be a quiet mosaic, each line marking the direction of a long-forgotten cosmic breath. Another aspect of this idea reveals itself when looking at the varying brightness of the filaments. Those formed during stronger eruptions might glow more brightly even today, carrying the residual energy of more intense outbursts. Others, shaped during more subdued events, might appear as faint whispers. The differences in brightness would then be like differences in age or intensity, natural variations in a long history of quiet eruptions. Some filaments appear bent or curved, as though pushed by winds or shaped by hurdles they encountered long ago. These curves may be the remnants of outflows that encountered gas clouds, bending gently as they pressed through. Over time, the bends softened further, leaving arcs that now float gracefully against the backdrop of the galactic center. The shapes evoke the soft movement of branches in slow wind, preserved across millions of years. If ancient eruptions are responsible, then the filaments might also reveal the energetic history of the black hole itself. By studying their direction and energy, scientists could reconstruct when the black hole last fed actively and how powerful its outbursts were. The filaments would serve as a quiet, luminous diary of the galactic core, written in narrow, shimmering strokes stretching across the dark. Outflows could also explain why some filaments appear to converge or fan out, hinting at a common origin point. These lines might trace the paths of particles launched simultaneously during a single episode of activity. Over time, as particles spread outward, the structures may have widened slightly but retained their cohesive shape. Observing them today is like seeing frozen rays of light radiating from an ancient lantern. Some filaments exist near large cavities evacuated by past eruptions, suggesting that they formed along the borders where energy compressed the surrounding gas. These boundary regions can be especially bright in high-energy wavelengths. In this view, the filaments are the peaceful edges of long-dissipated cosmic winds, glowing like faint embers at the rim of a cold fire. The ancient eruption model also helps explain the sheer number of filaments. If the black hole experienced many cycles of activity over millions of years, each cycle could have generated new paths, new shock fronts, new narrow channels of heated gas. Over time, these accumulated into a vast population of slender structures, like a forest of old branches in a windless night. What makes this idea especially soothing is that it offers both motion and stillness. It imagines a past full of energy and turbulence, but a present filled with quiet relics, softened by time. The filaments become tranquil remnants of cosmic storms that have long since faded, leaving behind gentle lines that drift peacefully in the dark. Yet the mystery remains, because the filaments, though possibly shaped by outflows, do not always align with the expected directions of ancient eruptions. Some lean at angles that make no sense in the context of black hole activity. This mismatch introduces a soft uncertainty, a quiet gap that keeps the explanation from settling fully. But that incompleteness only deepens the meditative quality of the puzzle. Another layer of the idea suggests that outflows may have interacted with the galaxy's magnetic fields in complex ways. As jets or winds passed through the region, they could have stretched and aligned the magnetic field, creating long, straight channels. These channels later glowed as electrons flowed through them. The combination of outflow and magnetism feels like a duet, two forces acting together to create delicate, luminous shapes. Some filaments appear to extend from regions where gas was once violently compressed, as if marking the edges of old shock fronts. These would be the ghostly traces of expanding shells of hot material, now cooled and quiet. Observing them today is like seeing the outlines of waves that once broke loudly but now rest in calm symmetry. If the filaments were born from ancient eruptions, then their presence today means the galaxy remembers. The structures act as long-lived archives, preserving the history of events that shaped the heart of the Milky Way long before we observed it. They are the galaxy's soft, shimmering memories, glowing faintly in the dark. Another thought drifts gently. As the black hole rests now in a quieter state, the filaments become markers of contrast, stillness following motion, calm after chaos. Their presence reminds us that even the most violent cosmic events eventually settle into silence, leaving behind only faint, elegant traces. The outflow explanation also carries a sense of harmony, as though the galaxy has found equilibrium. The energy once released has spread, diffused, and softened, leaving behind filaments that no longer race with fury but drift with gentle persistence. They are like feathers left in the wake of a bird that flew long ago, still suspended in the air. Yet despite all this, the idea is not fully complete. Some filaments do not fit the shape or energy expected from ancient eruptions. Others appear too fresh, too sharp, too precisely aligned to be remnants of events so old. These inconsistencies allow the mystery to remain open, a quiet pool of unanswered questions where the mind can rest without needing to reach any firm conclusion. And so the idea of outflows and ancient eruptions becomes one more soothing possibility in the soft tapestry of explanations. It is a vision of the galaxy breathing across time, releasing energy in long, slow cycles, and leaving behind narrow trails that glow peacefully in the silence. Whether or not this idea is fully correct, it invites the listener into the gentle rhythm of cosmic memory, where past events linger like whispers, forming delicate lines in the darkness for us to ponder in quiet wonder. Still other ideas drift softly into the mind, like quiet sparks from distant fires that have long since cooled. One of these ideas whispers that the filaments might be the remnants of stellar leftovers, the delicate signatures of dead, dying, or violently transformed stars whose final breaths carved narrow channels through the surrounding space. In this picture, the filaments are not reflections of magnetic fields or echoes of ancient eruptions but the gentle aftereffects of cosmic endings, shaped by the transitions of stars that once lived brightly in the crowded heart of the galaxy. Some filaments sit near the remains of supernova explosions, as though they were formed in the wake of a star's final collapse. When a massive star dies, it sends shock waves flooding outward, compressing gas into long, thin structures that may persist far longer than the explosion itself. Over thousands of years, these compressed regions cool, leaving behind elegant, softly glowing threads. The idea feels peaceful, that from the death of a star, something delicate and lasting could emerge, floating quietly through space like a drifting strand of silk. If supernova shockwaves created some of these filaments, their narrowness could be the result of the shock front aligning with existing channels of lower density gas. Shock waves tend to propagate more easily where resistance is minimal, creating elongated shapes rather than broad, chaotic structures. As the shock wave expands, it pulls electrons into motion along its edges, causing them to emit faint radio or X-ray light. These emissions linger long after the explosion fades, leaving behind a serene residue of once violent energy. Some filaments also appear to lie near young, energetic pulsars, the compact remnants of dead stars that spin with incredible speed. Pulsars produce strong magnetic fields and narrow beams of particles that shoot outward like cosmic lighthouses. These particle streams can carve slender trails through the surrounding medium, lighting up the paths they create. In this view, The filaments are footprints of pulsars wandering through the galactic center, their beams sweeping silently, leaving shimmering trails behind them. It is soothing to imagine a pulsar passing quietly through a dense cloud, its high-energy particles illuminating the path like dust catching sunlight in a dark room. Over time, the path fades but does not vanish, preserved as a filament glowing faintly against the emptiness. These trails could stretch for dozens of light-years, as the pulsar continues its lonely drift, leaving a slow, graceful mark on space. Another gentle idea is that cosmic collisions, interactions between clouds, stars, and energetic winds may have shaped some filaments. In such environments, compression can occur along narrow fronts, creating elongated structures where particles accumulate and emit radiation. The filaments would then be the slender boundaries between colliding flows, frozen where two currents met and pushed against each other like soft, shifting tectonic plates. Some filaments appear in regions where fast-moving stars, so-called runaway stars, have plowed through the surrounding medium, their motion creating bow shocks. These shocks can stretch into long, graceful arcs that glow as electrons interact with magnetic fields. The thought of stars silently carving paths through the dense galactic center, leaving glowing trails behind them, carries a quiet beauty, like ships sailing through fog and leaving luminous wakes. It's also possible that old stellar winds created some filaments, gradually sculpting the surrounding gas into narrow shapes. Massive stars blow powerful winds throughout their lifetimes, shedding material that collides with its environment. Where these winds meet resistance, they can compress the gas into ribbons, which later shine when filled with high-energy particles. Over time, the star fades or dies, but the ribbons remain, peaceful relics of the star's long and gentle breathing. Another idea suggests that binary stars, pairs of stars orbiting each other, may have created some of the structures through repeated cycles of mass exchange. As material flows between the two stars, it can form narrow streams that extend far into the surrounding environment. If these streams are later energized by shocks or magnetic interactions, they could glow like thin, ethereal lines. This scenario paints the filaments as the slow, quiet signatures of stellar partnerships that lasted for millions of years. There is also the possibility that small clusters of stars created collective outflows, shaping the gas around them into narrow spokes. These clusters, packed tightly in the galactic center, generate winds that merge into strong directional streams. Where these streams collide with the surrounding environment, thin structures can form, glowing softly as electrons spiral through magnetic channels. The filaments would then be communal relics of stellar neighborhoods long faded into silence. Cosmic collisions between dense clouds could also leave narrow interfaces where ionized gas glows in radio wavelengths. These interfaces, once active and turbulent, may calm with time, leaving behind straight or curved filaments like the outlines of waves that once crashed with force. This vision offers a gentle sense of transformation, from collision to quiet, from chaos to calm geometry. Some filaments lie near regions where massive stars recently formed. These areas are filled with intense radiation capable of carving narrow paths through gas and dust, burning through the material in thin beams that later glow. As the stars age, the region cools, leaving behind delicate, thread-like remnants of once fierce radiation. This explanation carries the soft feeling of embers cooling after a fire, still warm but no longer bright. Another calming idea is that black holes smaller than the central giant, so-called intermediate mass black holes, might have wandered through the region, dragging gas and particles along narrow tracks. As they moved, their gravitational pull could have stretched material into lines that remain visible today. These hidden travelers, silent and unseen, might have left behind trails that now shimmer faintly in the dark. Some filaments appear twisted or braided, as though shaped by interactions between multiple stellar remnants. If two pulsars or stellar winds collided, the resulting flow could braid gas into elegant patterns. Over time, these patterns would harden into stable filaments, glowing softly with stored energy. This possibility adds a gentle sense of artistry to the cosmos, where even collisions can produce delicate, harmonious forms. Another potential source lies in microquasars, smaller black hole systems that can emit narrow jets much like the central supermassive one but on a smaller scale. These jets could carve slender paths through the galactic core, leaving behind glowing filaments that mimic the behavior of much larger eruptions. In this sense, the filaments would be miniature signatures of energetic events, preserved long after the systems quieted. Some filaments may be the relics of gamma-ray bursts that occurred millions of years ago. Though rare, these bursts are powerful enough to carve narrow beams through surrounding material, creating channels that remain long after the initial flash fades. These channels, now faint and serene, could be among the longest filaments observed, lingering as peaceful remains of once inconceivable energy. Another soft idea involves tidal interactions, events where stars passing too close to massive objects shed material along stretched lines. These tidal tails can glow for long periods before dispersing, appearing as narrow filaments that trace the star's journey. Imagining such a star drifting by, slowly pulled apart, leaving a glowing thread behind it, carries a quiet melancholy, like a memory stretched thin. Some filaments might also form where cosmic rays, high-energy particles, create narrow ionization trails through dense gas. These trails could persist for long timescales, especially if magnetic fields focus the particles into thin paths. Over time, the residual radiation would soften, leaving a faint, smooth glow along the length of the filament. There is even speculation that dark matter interactions, though extremely subtle, might indirectly produce narrow energy channels in certain environments. While highly speculative, the idea carries a quiet intrigue, that something invisible and elusive might leave behind delicate imprints on the surrounding gas. Even if unproven, the thought rests softly, offering another gentle possibility. Some filaments appear to mark the edges of ancient cavities created by clustered supernovae. These cavities, blown out by multiple explosions, can have sharply defined boundaries where gas is compressed into slender lines. Over time, the central region fades, leaving only the softly glowing border as a long, narrow filament suspended in space. Observations also suggest that colliding winds from massive stars can form narrow shock regions where electrons accelerate and produce radiolight. These regions, once active and vibrant, relax into quiet filaments once the winds change or fade. The filaments then become settled remnants of dynamic interactions that lasted for countless centuries. In some scenarios, the filaments might trace the paths of slow-moving neutron stars, whose magnetic fields create narrow tubes of energized space around them. As the neutron star drifts, the tube stretches and becomes visible only under certain conditions. The resulting filament is like a gentle trail left by a wandering ember, glowing softly as it moves through cosmic darkness. Another idea is that these filaments could be the byproducts of interactions between cosmic rays and dense molecular clouds. Where the rays strike the cloud edges, narrow paths of ionization form and eventually stabilize into long, faint structures. As the cloud moves or disperses, the filament remains, a soft imprint of an interaction now long faded. Some filaments exist in pairs or groups, suggesting they may have formed from multiple events occurring nearly simultaneously. Perhaps a cluster of stars went supernova within a short time, or multiple pulsars passed nearby, each carving its own trajectory. Over time, these paths may align or overlap, creating sets of filaments that seem to speak to one another in quiet symmetry. The variety of shapes, lengths, and brightness among these filaments hints at a history rich with interactions, a dense environment where stars lived, died, collided, and transformed their surroundings. Each filament may be a chapter from one of these stories, frozen in time yet glowing softly enough for us to find it millions of years later. This idea carries a soothing sense of cosmic storytelling, where the galaxy keeps memories in the form of luminous lines. In the end, the idea of stellar leftovers and cosmic collisions offers another peaceful way of understanding the filaments, not as signs of perfect order or ancient eruptions alone, but as the gentle traces of countless stellar lives playing out in the dense heart of the Milky Way. These filaments become soft, glowing echoes of births and deaths, wanderings and meetings, woven quietly into the fabric of space, waiting patiently for our eyes to discover them in the dark.